Okay, area and volume, example number 1, and don't forget to download the file. Anyway, here we go. We are going to find the area of the region bounded by this and that. So have a look of a picture. Let's say we have square root of x right here. Let me just put this down. This is y equals square root of x. And then we also have the other equation, which is 1/2 x. So I will just put it down like this. Let's say here is y equals 1/2 x. They are going to cross each other here and here. But anyway, let's focus on this region. We have to find the area. And I will show you how to do the vertical rectangle approach first. To do so, first, of course, you draw a vertical rectangle somewhere. And it doesn't matter if you draw the left end or the right end. Doesn't matter. Because this rectangle is meant to be very, very skinny. And then we will have infinite amount of them, right? Just focus on the labeling. First of all, of course, we know the area of a rectangle is base times height, or the width times length, right? Focus on the base right here first. This right here is just a small change in the x direction, or the x value. This right here, we'll label it to be dx, right? And then for the height is this to that. And you have to remember, it's always top minus bottom. So you will have to do the top y value minus the bottom y value. And because the y value changes, of course, you have to refer back to your equations. And because we are in the x world, we are going to write square root of x for the y on the top. Yt stands for the y on the top, right? So this is the top function. And then this right here is the bottom function. And again, y on the top minus the y on the bottom. But you write it as this minus that. So first of all, let's go ahead and write down the area. For the height, it's again this minus that because we are in the x world. So you have to write down square root of x minus 1/2 x. This right here is the height of the rectangle, and then we multiply by dx. Now this is the area of this rectangle, and then we have infinite amount of them from here to here. We have to add up everybody. How do we do that? Yes, integral, and that's what the shirt is for. Anyway, integrating, well, because we're in the x world, we have to find out what's the x value from here to here. So we have to solve some equation. So I'm going to set these two equations equal to each other, and let me do it on the side. Square root of x, we'll have to put this equal to 1/2 x. Make them equal to each other and solve it. Multiply by 2 on both sides. 2 square root of x equals x, and then square both sides. And we see this is 4x, that's equal to x squared. And then move this to the other side. We get x squared minus 4x equals 0. And then just factor it. You will see that x is equal to 0, x is equal to 4, right? So with that being done, we know that we will just have to go from 0 to 4 because this is 0 and this right here is 4. That's it. This is the vertical rectangle approach. Well, what if you wanted to do the horizontal rectangle approach? Is that possible? In this case, yes, and it's also a good practice to have a look right here. So let me just repeat what we did earlier. Here is square root of x, right? This is y equals square root of x. And then we have the y equals 1/2 x. So this is y equals 1/2 x. Now, for the horizontal rectangle, of course, you come to the region here. You draw a horizontal rectangle. And then focus on the labeling. First of all, how would you label this part? Good. dy, right? This right here is just a small change in the y direction, so it's just dy. Very nice. And then, how about the height? This time it's kind of being, horizontal, so you can call this to be the length or the width, however you want to say it. But anyway, to figure out this distance, the other dimension, we will have to do the right minus left. The x on the right minus the x on the left. So remember, it's always the right minus left, the top minus bottom, okay? So, if you look at this, the x equation on the right is the blue one. And in fact, because we'll be in the y world, I need to get the x by itself. It's not so bad to do it because we can just multiply by 2 on both sides. So you see x is equal to 2y. And again, this is the x on the right. So I'll just put down xr, just like your iPhone XR. And then right here, of course, the x on the left, I will have to square both sides. In another word, x is equal to y squared, and this is the XL, like supersize XL, super large or extra large. All right, now here is the area. First of all, focus on the red rectangle. The base, in this case, is dy, and then the length is this. I will just put down the right minus left. Again, you write down this in terms of y. We have 2y minus y squared, and then we multiply by dy. Very nice. And in this case, we are in the y world. So when we integrate it, be sure we go from y is equal to 0. And earlier we found out this is when x is equal to 4. Putting 4 into this x, maybe 1/2 of 4 is equal to 2. Or if you put it here, you also get 2. So this will go from 0 to 2, like this. Right? So this is how you find the area. And now let's move to the second part. Okay, second part, we are going to rotate the region about the x-axis, and then we will find the volume. I will show you guys both the washer method and also the shell method. So have a look here. First of all, of course, let's go ahead and draw the region again. Here is the square root of x, and here is the 1/2 x. And of course, we are talking about this region, and we are going to rotate about the x-axis. So that's pretty much a typical picture that we'll do. And then, when we rotate it, just have to picture this in your head. First of all, you will have an outer piece, and then minus the inner part. So what you do is the following. When you rotate about the x-axis, the square root of x will be on the outer part. So you first draw the outer part, which is like this. And then you do a mirror image down below. And then the bottom is the base right here, just kind of do oval so you can make it like three-dimensional looking, okay? So this is the x-axis, and this right here is the y-axis. And then you know that when you rotate it, there will be one part in the middle that's missing. So you will have to subtract. Take this blue line and then you rotate about the x-axis, you will actually get a cone like this. Right? So let's just go ahead and make a quick sketch. And in fact, people call this the washer method. It's actually just nicely equal to a disk method question right here, and then minus another disk method right here, all right? So that's the picture that we will have. Okay, and remember the little numbers. First of all, let's write down the equations. Y is equal to square root of x. The other one is the 1/2 x. And then this right here from earlier, we know this is equal to 0 and 4. And we also have the 2. So just keep all those numbers in mind. Have a look here. Right here, we are going to find the volume by using the disk method. So what you do is, you draw pretty much like the vertical rectangle. Rotate that, you actually get a disk. So you actually just draw a disk. A very thin disk, like this, okay? And as you can see, the oval kind of match with the oval of the big one. Anyway, it's all about labeling. And you also have to remember, the volume of a cylinder is pi r squared h. The volume of a disk is pi r squared times the thickness. Labeling, the thickness right here is dx. Very nice. Second part, the radius, which is from the axis of rotation to here, and of course that'll just be our y, that's just the y, yeah? And because we're in the x world, we know y is not allowed, but this y is the same as square root of x. So we'll just put that down in a second. But anyway, for the volume for this one, it's equal to, let's just put down pi, and then again, y is the square root of x, so I'll just put this down, square root of x, and then we have to square that. So you see pi r squared, and then times the thickness, which is dx, just like that. This will give you the volume of this red disk. And then we just have to add them up. And because we're in the x world, we just have to go from 0 to 4 and add them up by using integration, just like that. Very nice. And usually, you may see people just put like both of the things inside of one integral, but I think that's confusing sometimes. Because sometimes when you are doing rotating about like x is equal to -1, you have to do subtraction of like a different subtraction for the radius. I personally prefer to break it down into two integrals. And you can see that this is actually just a disk method question. And again, you get another disk method question right here. And when you have subtraction going on, when you have the hole in the middle, that's called the washer method, right? Anyway, right here, do the same thing. I will just draw a disk. It's pretty much the same thing now because you'll see that the thickness is still dx, and this right here is our y, but the y is 1/2 x. So this right here is not so bad now. Pi r squared, and the r is our, oops, wrong color. Blue. Pi r is y, which is the 1/2 x, right? 1/2 x. And then you square that, dx that, integrate that from 0 to 4. And yes, you can put this instead of that, but as I said earlier, if I write it down separately, it will be more clear, in my opinion, right? So this is the so-called washer method, because again, just like washing machine, there's like a hole in the middle. Well, what if I want to use the shell method? Have a look here. What I do with the shell method is that I will just kind of rotate it, and I'll just give you a whole picture, which is like the whole thing, but we have a hole in the middle. So again, I will just draw like this, right? And then I'll do the mirror image, and then I'll do like this, okay? And then I will stick this in. That's the x-axis, and then we have the y-axis. And we also have the inside, which is this line. And then again, you just have to do like this, and you have to remember that it's actually just this part that's actually the solid part. And the middle is the hole. So keep that in mind. Now, the difference between the disk and also the shell method is that you will see if you have dx for the disk, you will always have the other one, namely dy for the shell. And the reason is because in order to draw the shell, which is just like a piece of paper, you can just imagine a shell is just like this right here is a cylinder, and take it out. This is a shell of the cylinder, and you pretty much have a rectangle. And you have to remember the 2 pi r for the circumference, and then times the height times the thickness. Okay, so for this one, we will actually begin by drawing a shell, and it actually is a horizontal rectangle situation. What we do next is you mirror image that down here, and then here you just go ahead, you draw the oval so you can see. This is like the shell, which is just like a tube that I'm trying to draw. Like that, isn't it? All right, and then again, it's all about labeling. First of all, this thing has a thickness, which is right here. In that case, it will be dy. Always pay attention to if it's dx or dy first. And next, go for the radius. And of course, the radius is actually just from here to here. And notice this right here, it's very similar to our labeling earlier. And right here, we'll just label it as y. And the good thing is that y is allowed in the y world. So we'll just use y for the radius. Then we go for the height. The height is just going to be this to that. You see, it's this to that. It's just like our horizontal rectangle situation for the area. What do we have to do? Yes, we will have to do the x on the right. So let me just put this down here for you guys. For this part, we have to do the x on the right minus the x on the left. Well, what's the x on the right? Look back to this. The x on the right is, of course, the blue one. If you are coming toward this right here, you know the blue one is the one on the right. I will have to solve for x in terms of y here first, because we're in the y world. So x on the right, it's the same as 2y. And similarly, the x on the left is just you square both sides, you get y squared. So this right here is actually just equal to 2y minus y squared. And that will be for the height for that. And now we have all the ingredients, and I'll put on the volume for you guys right here. Well, 2 pi times the radius, again, that's the circumference formula, right? And the radius is the y, which I will just put on 2 pi y right here. And then we have to multiply by the height, which is this minus that. And we are in the y world, so 2y minus y squared, and then the dy. Very nice. And then integrate that from 0, yes, to 2. So this right here is the shell method. And maybe you notice that if you have hole in the middle in your solid, maybe the shell method is a way to go. And of course, that might be the situation because when we have a shell, there's nothing in the middle in the first place. So of course, it works out really well for this kind of situation, right? But the disk method minus another disk method, it's not so bad either. And of course, the more you do it, the better you will get. So let's go ahead and get to the next one. Okay, so for this part, we'll take the region and rotate about the y-axis. Have a look here. First of all, this is the picture, square root of x, and then 1/2 x. And of course, this is our region, and we are rotating about the y-axis. This time though, the 1/2 x, it's actually on the outer piece, right? You have to take this part and rotate it. Well, let's see. I will just draw the 1/2 x and then mirror image that, and then do the oval like this, and stick out the y-axis, and this is the x-axis. This is like a martini glass. Look at that. So pretty. And then we have to minus because you all know this is a situation that has a hole again. I'll take this part, draw it, and then mirror image that, and then I will just kind of do the oval on the top. So this is the part that we will have to subtract. So that's the DEO. Now, a disk method minus another disk method situation, right? For this one, we'll draw a disk, and I'll just draw a disk like this for you guys first. And again, you see the oval has to be matched with the oval opening on the top. This time, the thickness, is it dy or dx? Good, it's dy, because that's the little part right here, that's dy, all right? And then we have to focus on the radius, which is from here to here. Well, the radius from here to here is just nicely equal to the x, right? It's just the x, it's just x, horizontally, of course. However, in the y world, x is not allowed this, so we have to look back to our equation. This is y equals 1/2 x. So we'll have to multiply the 2 on both sides. Anyway, this right here, let's go ahead and put down the volume. Pi r squared, the radius is x, but again, you have to write this down in terms of the y, which is x equals 2y. I'll just put down 2y right here, and then square that. And we are in the y world, so that's dy that, and then integrate that. From what to what? Well, it was 0 to 2. 0 to 2. So integrate this from 0 to 2, and we are done for this. Now, do the subtraction. And for this one, again, a disk method situation. Don't use the shell method in this situation, no. Shell method will just take care of everything, okay? Anyway, draw the disk again. It will look like this. Similar situation, the thickness is dy, and the radius is just x from here to here. But this time, look back there, we knew that y is square root of x, namely x is equal to y squared. So let's put down the following. Pi is pi, of course. The radius is x, which is actually y squared in the y world for this situation. And don't forget, the formula is pi times radius square, right? Even though you have the square right here, but this square is because x is equal to y squared, and you have to square the radius. And then you have to have the dy, and then again, integrating from 0 to 2. And there you have it. This is the washer way to do it. By the way, washer is not a name of a person, it's just a washing machine, that situation, right? Okay, now let's look at this with the shell method. Rotate this about the y-axis, so we will get the following. I will just draw the martini glass on the outside. So do this, and then you do the mirror image, and then you draw the oval on top, like so. And then you draw the square root, which is from here to here, and then you mirror image that. And then remember, you pretty much have to rotate that. You only have this portion, right? And then let's see, let's go ahead and make this more three-dimensional looking. All right, here we go. This time, well, remember we have to draw the shell, and the oval has to match with this, right? So the shell will have to sit vertically. If you would like, just kind of use your paper, or maybe if you're taking a test, just roll up your paper like this, and you see this is the shell. So the shell will look like this. Vertical rectangle, and then vertical rectangle, do the mirror image on that. Rotate, so you have the oval, and then you rotate, you have the oval like that. Okay? All right, dy or dx? Well, here is the thickness right here. This time, dx. And you see, earlier we used dy, this time it will be dx. They will always be opposite of each other, for sure. Next, radius. The radius will be from here to here. Well, that will be just x, because it's horizontal. And you see, the radius is very similar to what we did earlier. That's very nice. The last part is the height from here to here. Well, this time, be really careful. Right here, you see, we have the curve in black. This is the y on the top. And then we have the line on the bottom. This is the y on the bottom. So you have to do the subtraction, top minus bottom, for this right here. So this is y on the top minus y on the bottom. And look back here, the y on the top is square root of x, and then the y on the bottom is 1/2 x. We will have to do this minus that because we are in the x world. So with all that being done, here is the setup. The volume is equal to 2 pi times the radius, which is just x. And we are in the x world, so this x is good. Times the height, which is square root of x minus 1/2 x. This is the height, right? And that's it. 2 pi r times the height, and then you don't square anything, okay? Just keep that in mind. And then you multiply by the dx, and you integrate this from where to where? If you look back, the x value was from 0 to 4. So you just integrate this from 0 to 4, and congrats. You are done. This right here is the shell method. Very nice, huh? All right, this part, we are going to rotate the region about x is equal to 5. So of course, let's have a picture first. Well, of course, the original, this is square root of x, and then here we have the 1/2 x, right? This is the region that we have. And remember, they intercept at x equal to 4. And this time, we are rotating about x equals 5. So here is actually the axis of rotation. So I'll just put down this right here. This is x equals 5. Now, let's see. This time, when we rotate right here, the square root of x is going to be on the outer part. So I will have to draw that first. First, I will draw the square root of x, and there's a gap, as you can see, right? There's a gap right here, and then there's another mirror image of the gap. And then you draw the square root, mirror image that, right? And then just go ahead, do the oval, like this, okay? And then put down the x-axis, and then put down the y-axis. And this right here is our x equals 5. So this is the outer piece. And then we also have to minus the inner part. So minus, you take the blue line, and then here's the gap, mirror image the gap, and then you mirror image that. So like that. And then you draw this, and you draw that. So you have a pretty good 3D picture in like a couple seconds. Anyway, here is x is equal to 5, of course. All right, now, this method on this and this method on that. And be really careful this time because the radius is not as easy as the previous ones. So have a look. Well, right here, of course, again, we are using the disk method. So I will just draw the disk like this. We are putting on disk like that. And you see the oval match with the oval, which is very nice. First thing first, find out the thickness. In this situation, it will be dy, isn't it? Because this part is just a small change in the y direction. That's good. Next, we have to find out the radius. This time, the radius, I will have to draw it from here to here because our original picture, you see, it's only on the left-hand side right here. The left-hand side already, I'm sorry. It's on the left-hand side like this. The right-hand side here, it was just for me to draw the 3D picture. So our equation don't work for the right-hand side. Our equation only work for this part. So be sure you draw radius from here to here, all right? Now, the radius, you see, we will just have to go from here to here. We do not go all the way. So be really careful. You see, you have the x is equal to 5 right here. And this right here is your x from here to here. From here to here, that's the x distance. The whole thing from here to here is 5, and this much is x, right? This much is x. So this much right here, it has to be 5. Let me just put it down like this. 5 minus x, right? Again, it's always the x on the right minus the x on the left, just like that. So that's pretty much the idea. And now let's go ahead and just write down our integral for this right here. The volume is equal to the following. Pi is pi. The radius is 5 minus x. But what's x? Well, we have to look back there, right? Because we are talking about y is equal to square root of x. In other words, x is equal to y squared. So, in fact, for this x, because we'll be in the y world, we will have to use y squared. So now let's go ahead and put this down. We have 5 minus the x is, again, the y squared. This right here is the radius. And then we will just have to square this guy. And then dy this guy. And then integrate this guy from 0 to 2. Because we have done this a few times already. This goes from 0 to 2. This right here is for that. Not done yet though, because if you want to finish the whole thing, you have to subtract. All right, so another practice right here. Go ahead and draw your disk. Similarly, you see that the thickness is dy, very nice. And similarly, just look at this part because this is just for our 3D picture purpose only. We will have to go from here to here for the radius. The x on the right is 5. And then the x on the right is, from here to here, is just x. So I'll just put down x on the left. And this was the x on the left as well. But the equation that we used for that was x is equal to y squared. But this time, the equation that we have to use is the blue one. And you see, originally was y equals 1/2 x. So of course, multiply 2 on both sides, x is equal to 2y. So put the 2y right here for the xl on the for this situation. So let's go ahead. Pi is pi, and we have the 5 minus 2y. And then we square that, and then we dy that, and then we integrate this from 0 to 2. So congrats, this right here is our washer method. Right? So this right here is the washer. And again, the reason this is called the washer because we have something missing in the middle. Now, I will show you guys the shell method. It still works out pretty nicely. So have a look. If I will rotate this about x equal to 5, so it's pretty much you put this inside of that. So I'll try my best to give you guys a good picture. Here is the square root of x, and then we have a gap, and then mirror image the gap, and then you mirror image the square root. Something like this, right? Next, you have to draw the line. Mirror image the gap, and then you mirror image the line. So like this. And then you just go ahead and connect the top with the oval, and then connect the bottom like this. And then you have the x-axis, and then you have the y-axis. Right in the middle here is the axis of rotation, which is x equals 5. Whew. Again, focus on this part because this is where our equations are. Okay, good. This time we are going to draw a shell. So to do that, well, I will put a shell vertically, right? So just like this. Okay, so I will just focus on drawing the vertical rectangle right here first. And then I will mirror image that. And then I will just draw the oval on the top to make it three-dimensional looking, and then also oval on the bottom, like so. Okay, dy or dx? Yes, dx. Radius from here to here. What's the radius this time? Well, 5 right here, right? And then minus the x on the left, which is just x. And the reason that we just use x is because we are in the x world already. So the radius right here is just 5 minus x. That's it. You don't have to change that in terms of y. Next, we have to figure out the height, which is this and that. Well, have a look. We just want from here to here. And that's the y values. We have to do y on the top minus the y on the bottom. Look back. y on the top is square root of x, and then y on the bottom is 1/2 x, right? So for this one, let me just indicate that it's y on the top minus the y on the bottom. But we are in the x world, so be sure you use this and that. So now have a look. 2 pi is always 2 pi, and then you multiply by the radius. This time the radius is 5 minus x. So just multiply by 5 minus x. And then we multiply by the height. Again, it will be the square root of x minus the 1/2 x. So square root of x minus 1/2 x. And then you dx that. And then you integrate this from 0 to 4 because we are in the x world, and this right here is the volume with the shell method. Right? So seriously, it's not so bad. You just have to practice how to kind of just break things down and all the good things. And I have one more for you guys, but have a look here first. All right, so we will take the region and rotate it about y is equal to 3. Have a look of the picture first. So go ahead and draw our square root of x right here, and then this right here is our line 1/2 x, right? And as we all know, this right here is 4 and this right here is 2. This time though, we are rotating about y is equal to 3. So it's going to be up here. This is the horizontal line that we're rotating about y is equal to 3. This time, you see that the blue part will be on the outer piece when you rotate, and then the square root part will be in the inner piece, right? So this is going to give us the following. Let me just go ahead and draw the line, and then there's a gap, and then I will mirror image the gap, and then I'll mirror image the line, so it will be like this. And then I'll do the oval at the end. So that will be pretty much the idea, yeah? And then here, you see that, oops, this should be dashed lines, like this. This is y equals 3. And here you have your x-axis, and here you have your y-axis. Okay, so this is the first one. And for the next one, I will just draw in black, of course. This is going to be the subtraction situation. Subtract, this is the square root, and then we will have the gap. And then we mirror image the gap, and then we mirror image the square root, and then at the end, just do the oval like this. And then you just have the y is equal to 3, and this right here is the x-axis, and this right here is the y-axis. Okay, now, disk, right? So here we go. Let's go ahead and draw the disk right here. It's not so bad. dy or dx for the thickness? dx, good. Just right here. Now go for the radius. This time, you start from where we are rotating about, and you go down. This right here is the radius, because as you can see, our original equations, all that stuff is down below right here, right? The top portion is just for our 3D picture only. So from here to here is the radius. What's the radius though? Well, you see, the top y is 3, and then we have the bottom y. So we have to do the top minus the bottom. So this right here, it's actually 3 minus the y on the bottom. And the y on the bottom, just look back here, y is equal to the 1/2 x. So I'll just put down right here for you guys. This is the y on the bottom, which is actually this. Because we are in the x world, so we have to use that. So go ahead and write down the volume. This is equal to, we're using a disk method, so it's pi times radius square, pi times the radius, which is 3 minus yb, which is this now, 1/2 x. Square that, and you dx that, and you integrate this from 0 to 4, because we are in the x world. So just like that. Very nice, huh? Now, for the second one, we have to subtract, because we are taking this out, right? Again, a disk method situation. So I'll draw this right here. dx, just like that, and then, of course, the radius is from here to here. Notice this is 3 minus the y on the bottom. So we will have 3 minus, and the y on the bottom is this. Y is square root of x. So that will be our y on the bottom in this case, right? The black one. So now, of course, right here, we have pi times the radius, which is this. We have 3 minus yb, in our case, is the 1 right here, which is the square root of x because we're in the x world, and square that, and dx that, and then integrate this from 0 to 4. And congrats, this right here is our Washoe method for the volume, right? And now I'll show you guys how to do this with the shell method. So let's go ahead. We know that the blue one will be on the outside, so let me do that first. And then there's a gap. I will mirror image the gap, and I'll mirror image the line, so it will look like this. And then we have the square root. It will look like this. Gap, mirror image the gap, and then mirror image the square root. And then at the end, you just do this, and you do that, and here is your 3D picture. And this right here is y equals 3, and then this right here is our x-axis, and this right here is our y-axis. And the solid is actually this part. We have a gap in the middle, okay? So now, let's go ahead and draw our shell. And remember, our shell this time, it will look like this though, right? It will look like that. So what we'll have to do is draw the horizontal rectangle here, like that. And then I will mirror image the horizontal rectangle. And then I will just do the oval at the end, like this, and then like that. So that's pretty much my shell. It's like cylinder pretty much. But it's just a small piece like of the outside shell. All right, dy or dx? dy, good. Just this little part, right? So this is dy. And then radius will be from here to here. What's the radius? Top y minus the bottom y. The top y is 3, so let me just indicate that. Y on the top is 3, minus the bottom y is just bottom y, because we're in the y world, so this is totally okay. And then what's the height? Well, again, look at this. This time, have a look. The height is from here to here only, meaning that we have to do the xr, meaning x on the right, minus the x on the left. And of course, we can just refer back to our equations. The blue one is on the right, so have a look here. I will just, of course, multiply both sides by 2, so x on the right is 2y, and of course, the x on the left is y squared. And we're just doing this minus that in the y world. So now, the volume by the shell method is equal to 2 pi times the radius, and the radius is just that, namely 3 minus y. Good. And then we multiply by the height, which is this portion. Well, xr is 2y, and then minus the xl, which is y squared. And then we dy this guy, and then we integrate this guy from 0 to 2, because we are in the y world. And congrats, this right here is it. This right here is the shell method, and earlier we did the washer method, right? So hopefully this video has helped you understand how to do the shell method and the washer method whatsoever, especially for the labeling and also the breakdown, especially when you have to rotate about like weird places such as y is equal to 3 or x is equal to 17 or y is equal to ln5 or something like that. I don't know, but hopefully you guys can see the breakdown and all the good stuff, right? And maybe later on work out some other examples from the handout, but in the meantime, be sure you actually try the questions first, okay? So anyway, as always, that's it.